Or go back to chapter 7. I'm going to go to 7.3, which is on logarithmic functions. And this follows from exponential functions. Logarithmic functions are just the undo of exponential functions. So, like if I said 2 to the x equals 10, it'd be hard-pressed to figure out x without knowing how logs work. So you can tell that it's going to be between 3 and 4 because 2 to the third is 8 and 2 to the fourth is 16, and 10 lies between them. You can tell me that, but you can't get more, you wouldn't be able to get a whole lot more precise than that without, doing some trial and error. Or using your calculator and the intersect function. So you could do that as well. But the way to solve these is actually to use logs. I'll show you how a log works. For the first example, I actually have some true log statements. This is how it's read. This is read log base 3 of 4. So if I say log base 3 of a 4, that looks like that, or not a 4, excuse me, of 81 equals 4. Of 81 is 4. So that's log base 3 of 81 is 4. That's how you would read that. Log base 3 of 81. And it equals 4 for this reason. I liken this to building a house. I've got some logs. I've got logs, so I'm going to build a house. Every good house needs a base. The base of this house is 3. So I start with a base. Then I go get the roof. Go to Menards or something, go get my roof. That's up high, that's my power through exponent, 3 to the fourth. And then that makes it look like my neighbor's house, which is an 81. 3 to the fourth is 81. True statement. Okay? That's how logs work. Moving on down. Here I've got a different type of log. It's a base 2 log. So I'm going to build a different type of house. Base of my house is going to be 2. I'm going to go get my roof, which is -4. And that looks like my neighbor's house, which is 1/16. 2 to the -4th is 1/16. A little review of the negatives. 2 to the 4th would be 16. If I put a negative here, that just tells you to flip it over 1 over. Okay? So you have 1 over 16. That seems to be the trickiest thing we encounter, is having those negatives there. So be aware of that. If you have a 1 over, just kind of ignore the 1 over and think what positive number would get me to where I want to go. And then because you have that 1 over, put a negative there. C has got something special here. C doesn't have a base here. It's not written anyways. It does have a base. When it's not written and you just have log, you say log means it's log base 10. And so if there's no number there, you can put a 10 there. And that should make sense because if you build your house, you would start with 10, go get your roof, so you'd have 10 to the third, and then that looks like your neighbor's house. The last one's got a special log. It's called the natural log. Ln is the natural log. And natural log means log base E. That E that we talked about a while back, the 2.718, goes on forever and ever because it's irrational, just like pi. So you could rewrite this problem as log base E of e to the -3rd equals -3. And you could build your house, start with your base, go get your roof, and then it's the same as your neighbor's house, which is kind of big in this case, e to the -3rd. And hopefully you agree with that. E to the -3rd equals e to the -3rd. Those are rewriting logs and exponential form. Okay, next one, we're actually going to evaluate. I want to figure out what would go here. So the ones you have to evaluate, you're going to be able to do mentally, or if you got your half power sheet there that I've given you, your half sheet with the powers on it, you can use that. Still build your house. So I got 4 to the x equals my neighbor's house. And I want to find out what x is. Well, 4 to what power is 1024? If you use your sheet or do a little trial and error, you find out that it needs to be 5. So x is 5. That's your answer. On a test, put x equals 5. Don't write 4 to the 5th equals 1024. I want to just see that you know that the answer is, in fact, 5. 2b. Start with my base. Go get my roof. Want it to equal my neighbor's house, which is 27. Here I've got that fraction. Could be a little confusing, but it's really not that bad. Just ignore the 1 for now. Pretend like it's 3 to the x equals 27. If you see that, hopefully you're going, oh, x is 3, 3 to the 3rd is 27. But because this was a 1 over on the left side here, that means this is actually negative 3. So that's how you get it flipped over. Okay, moving on. Third type of problem, we're going to have something in power form, then we're going to write it in exponential, or in a logarithmic form, excuse me. So I'm going to write this as log. This would be log base. What's the base? The base is 5. Of 25 equals 2. You still go back and forth. So you start with the 5, go over the 25, and then the 2 is on the other side. Log base, what's the base? The base is 1/4 of 64 equals negative 3. C, what's the base? The base is 10, so you could put a 10 there, but I don't need a 10 there because log base 10 is just plain old log of 1 over 100 equals negative 2. And the last one I have on this side, log base b of b to the x. I want to know what log base b of b to the x equals. I could rewrite it. It'd be b to the, I don't know, equals my neighbor's house. And hopefully you can see that the question mark, what I want to find, it has to be the same thing as x. They have the same base, b, and so they need to have the same power, or exponent, which would be x. So that's just x. In the future, we're going to want to be able to look at something like this and say, when this base down here is the same as the base of a power there, this whole thing just cancels. That'll allow us to solve the equation like I started off with. So I started you off by saying, we're going to need to be able to solve things like, this is really slow, come on. Well, apparently I erased it. But anyways, if I had like 2 to the I equals 2 to the x equals 10, you're going to be able to solve this by doing log base 2 of both sides. Because this will cancel, and the kicker is then how do you do log base 2 of 10? That's something we'll have to learn. Okay? Okay, a little technical difficulty, hopefully I got that figured out. We're going to now find the inverse of a log. Finding an inverse of a log is, well, we've done inverses before. It's basically a 4-step process. First step, switch x, y. Second step, isolate the log. Third step, rewrite in exponential form. And lastly, isolate the y. If that was too fast for you, make sure you pause it here to get those written down. But that's our 4 steps in finding the inverse of a log function. So we'll go through a couple examples here. The first one, switch x and y. Then I'm going to isolate the log. Now you need to understand that the log consists of a base and then something right next to it. This log has a base of 10. Remember when there's nothing down there, it's a 10. And it's something next to it is a 3y. It's not the 2. That, in order for the plus 2 to be next to it, you'd have to have parentheses around the whole thing. And then that would be an entire log. But the parentheses weren't next to it, so I get rid of those. We have to get the log alone. That means we have to minus the 2. So make sure you subtract the 2 over. So x minus 2, this is step 2, is log base 10 of 3y. Now the log is isolated, so now you can rewrite it. And the rewrite would be build your house. I've got a log build your house, so it's 10 to the x minus 2. Go get your roof. And then that equals your neighbor's house, which is 3y. Finally, get the y alone. There's a 3 next to it, so we're going to divide over the 3. Okay, we've got one more of those. If you want to try that, see how you did. Switch x and y. Isolate the log. What's not part of the log on this one is the 2. So I'm going to divide over the 2. Now I'm going to rewrite it. My base is 3. Go get the roof. Equals my neighbor's house. Notice how the y minus 5, that was all part of the log on this one because it was in parentheses. And then finally get the y alone by adding 5 at the end. That's finding an inverse. One last thing we need to do is graph. So I'm going to go to my graphing page here. The graphs of logs are the inverses of exponential functions. We did exponential functions some time ago. Here's a basic exponential function. Every basic exponential function had a horizontal asymptote of y equals 0. And then we plugged in some points here, like -2, -1, 0, 1, 2. And then we did 3 to them. 3 squared is 9. 3 to the first is 3. 3 to the 0 is 1. 3 to the -1 is 1/3, 1/9. So every one of these basic ones had a y-intercept of 0, 1. And they all look like this, where they curved up and then curved down towards that asymptote. The domain was all reals because it went forever left and forever right. The range was all reals greater than 0 because you couldn't go any lower to 0. You couldn't equal 0. Everything was above that 0 mark. And again, it was a horizontal asymptote of y equals 0. Well, what happens for a log is you find an inverse, so that all that does is you've got this line y equals x, and all these points are reflected over y equals x. So 0, 1 becomes 1, 0, 1, 3 becomes 3, 1. And what you end up with, and your horizontal asymptote turns into a vertical asymptote. And you end up with a graph that looks like this. And hopefully you can see that my green line, the symmetry there, that makes sense. That if I flip the blue over that line, I end up on the red. That's what a log function looks like, the red graph. In fact, that log function we just graphed is the one down low here. Y equals log base 3 of x. That is the inverse of y equals 3 to the x. I don't know why this thing decides it's got to move on its own. There we go. Okay? Mind of its own. Alright, so how do I graph y equals log 3 base 3 of x? I want to know that there's a vertical asymptote, and I draw that in all the time. And don't forget to put that it's x equals. So I got x equals 0. Then I want to find some points on there. Now you don't need 5 of them. I just need some easy ones that'll work. You could take the ones up above there that we found and then just switch the x and the y's. But I would rather you go 3 to some power over here equals some easy number. What would be an easy number to plug in? Well, 1 would be an easy number to plug in because log base 3 of 1 is 0. 3 to the 0 equals 1. 3 would be an easy number to plug in because log base 3 of 3 is 1. 3 to the 1 is 3. So when I plug in 3 right here, I get 1. One more. If I plug in 9, this should be 2. My y would be 2 because 3 squared is 9. So I grab 1, 0, I grab 3, 1, and then 9, 2 is over here somewhere. And I've got that curve that I graphed up above. So again, the difference is you have a vertical asymptote, and this will also switch your domain and range. Your domain now has a limit. It can't be any smaller. It can't equal 0, and it can't be smaller than 0. It has to be to the right of 0, greater than 0. But it goes forever up and down, so my range is all reals. Okay, down here, I've got a log function that's got a bunch of transformations on it. Come on, there you go. But the parent function is exactly the one I just drew up above. The parent function is y equals log base 3 of x. So I can base this up above off the numbers I just plugged in. I plugged in 1 and got 0. I plugged in 3 and got 1. I plugged in 9 and got 2. And just go through the transformations that we did throughout the year. What are those transformations? Well, this 2 out front here tells me I have a vertical stretch of 2. So I multiply all the y's by 2. The plus 1 tells me to go left 1. So that's subtract the x's by 1. And the minus 3 at the end tells me to go down 3. That affects the y. There's my new coordinates. When you graph this, think about which one affects the vertical asymptote. What affects the vertical asymptote? Well, the only thing that can affect it is the thing that affects the x, because the vertical asymptote is x equals. What affects the x? This right here, the one to the left. So my vertical asymptote started here. Moving this up and down does nothing. Moving it or stretching it does nothing. But if I tell you to move everything to the left, you've got to move this all to the left. That's your new vertical asymptote. It's at x equals -1. And you just plot your points in. 0, -3, 2, -1, and 8, 1. Draw your log curve. Identify domain and range. My curve goes forever to the right, but gets stopped at -1, so it's all reals greater than -1. These two numbers here are always the same. And then my range would be all reals all the time. It goes forever up and down. So that's the basics of graphing the logs. You need to think about what numbers would work. Understand you have a vertical asymptote. Be prepared to identify domain range. Thanks for watching. Have a great day.